Hello chemistry class. This is station 1 of your station lab, balloon in a bottle. So what I'm going to do is I'm going to pull this off of the hot plate, and there's boiling water inside. I'm going to take this balloon and I am going to stretch it over top of the opening. Now I'm going to try my best to center it. Our results will be slightly better if we do that. And after I have this balloon centered, watch what happens here as it starts to cool. I'm actually going to speed this process up a little bit. I'm going to run it under cold water. Now you can already see it starting to happen here. You can see the balloon, there we go, is getting sucked into the bottle, into the early violet flask. And if I run this over under cold water, what do you think will happen? Should speed it up, right? Think about what's happening here. Oh wow, look at that. So it's almost completely filled the entire flask. Let's see if I can fill the entire thing by running it under cold water. So if you look, the balloon has completely inverted inside of our flask. Why did that happen? This is station number 2, rigid container. What is this bulb? Here we have a metal bulb that has been welded shut. So inside is trapped gas, and this trapped gas is connected here to a pressure gauge. So this container is very rigid. It's not going to change in its volume when we place it into our hot water bath and our cold water bath. But we are going to explore what happens to the pressure as a result. If we look here, currently the pressure gauge is reading slightly less than 15 psi for room temperature. Now we're going to place this into the hot water bath. You should see the needle rising. So if I look, it is currently at approximately 18 psi. Okay, it's at approximately 18 psi. Now if I take this and I place it in the cold water bath, we should see the pressure decrease. If I look, it is at 14 psi. And if we let it sit in here for a couple more seconds, it should decrease even more. We are now at 13.5 psi. Okay? That is station number 2. Okay, this is station 3, hanging weights. I have here a syringe with a hanging apparatus on it, and this syringe has a plug on the end that stops air from escaping. I have set this syringe to 12 cc's. It's probably a little challenging for you guys to see in the video. 12 cc's, cubic centimeters. 1 cubic centimeter is 1 milliliter of volume. So this is like 12 milliliters of volume. So let's explore what happens as we add these weights to our apparatus. So as I add weight, you're going to notice that what happens to your volume? Well, your volume decreases. And this is decreased to approximately 10 cc's, 10 milliliters. If we let it sit for a little longer, it might go a little bit more than that because there is some friction within the plunger system of this syringe. But we're not super interested in that. We are going to hang now more weights. So it looks like it's bottomed out at about 9.9 milliliters for one weight. So when we add a second weight, let's see what happens. So our volume has decreased again, but one thing you will notice is this time it only decreased to about 8.2 milliliters. So we didn't see an equal decrease for the first weight and for the second weight. Let's add another one. If we add a third weight to this, and again, it looks like we are still at 8.2 milliliters. We add a third weight. We have gone down to about 7 milliliters. So about 7 milliliters on that one. Let's add a fourth weight to our apparatus. I'm going to try to do 6 weights here, but this is already getting a little hard on our syringe. So with 4 weights, we are down to 6 milliliters, or slightly less than 6 milliliters. Let's go with a fifth weight. With our fifth weight, we have gone down to about 5.4 or 5.3 milliliters, so about 5.35. And lastly, let's add the sixth weight. And with the sixth weight, we are going down to, it looks like it's flatlining out at about 4.8 milliliters. About 4.8. Now keep in mind that each one of these weights is equal in mass. They are all approximately 500 grams. So it's not that the masses are different. The masses I'm adding are exactly the same. However, you'll notice that that decrease in volume is not constant. The more mass we add, the less change we see. So think about that. Now let's see what happens when I remove all of these weights. So let's take these weights off and let's see what happens to our volume. As I remove these weights, we should see that our volume starts to increase, and it is. We're at about 6. Now it's shooting up. We're going to 6.5. It's shooting up even more. We're 7, 7.5. Take off another. You know, we're 8.5, going towards 9. Take off another, and it's shooting up now. We're 10.5, almost 11. And keep in mind, there is a little bit of friction in this system, so we probably won't go all the way back to 12. Yeah, we're about 11.5. If I were to leave this for a long period of time, it probably would eventually go back to that 12 or very close to it. So if I give it just a little bit of help, just the tiniest little bit of force here, there we go. It's right back to 12 cc's. This is station number 4, crushing a can. Here I have a can with approximately 10 milliliters of water in it, and I've heated this water up to a boil. Now when I take this can and I invert it into the cold water bath right here, watch what happens. Ha. Oh, I love that one. All right, so the can instantly imploded. Now take note, this can has not turned upside down, right? I've just inverted it. Watch how much water drains out. That is way, way, way more than 10 milliliters. And if we take a closer look at the can, you can see that it is completely imploded, right? It is completely imploded. Now again, there's nothing fancy about the can. It's just a regular, ordinary can. All I've done is put boiling water in it and inverted it into a bath of cold water. Okay, this is station number 5, hot syringe, cold syringe. Here, I have a thermometer. Now, this thermometer has not been in either the cold water bath or the hot water bath. It has just been sitting on the counter. I don't know if you can see it in the video here, but this thermometer is currently reading 21 degrees Celsius. Okay, so it is reading 21 degrees Celsius. Now, if we look at our syringes here, both of them were set originally at 5 cc's. Now, that's 5 milliliters. If I look at my cold syringe, which has been sitting in this cold water bath for quite some time, the volume now reads approximately 4.5 milliliters. And if I look at the hot water bath, the volume currently reads 6 milliliters, 6 cc's. So again, the cold water bath, the volume has changed to 4.5 cc's, and for the hot water bath, the volume has changed to 6 cc's, 6 milliliters. So now you have all the information you need to calculate the temperatures of your cold water bath and the temperatures of your hot water bath.